It's really lovely, and it's also a bit daunting, because I know pretty well everybody in the room, and I know that even if you don't say things publicly to me, privately you'll tell me whether I've either done a good job or not such a good job later on. I might see you in the bar later. May I also therefore extend my welcome to you. As many of you will know, the Cambridge Maths team will talk to pretty well anybody who's interested in mathematics education. And I think you can tell from the wealth of expertise just from the people who are the facilitators that we have invited a very wide selection of people here. So you're all here because you have an interest in mathematics education, and not only an interest but also an awful lot of expertise. And without input from all of our friends and colleagues, not only in the UK, but also internationally, we wouldn't be in the position that we are now. So partly today is to thank you, those of you who have been involved, for contributing to our progress. We have got these aims for the day. So apart from saying thank you and sharing our progress, we've got 3 sessions with some questions which are sort of ongoing interest to us. So the first one about whose curriculum is it anyway? We've been working and talking to lots of international colleagues, and it's very interesting to understand what the policy decisions are that are made in different countries of the world and how the curriculum itself gets designed. Who is it who should determine what happens actually in the schools? The mathematics curriculum we have in the UK is not very different from the mathematics curriculum that I studied. Is that a good thing? Should it be the same? Is there a core part of mathematical knowledge that doesn't change at all? Or are we missing a trick because the world is moving on? So I'm really looking forward to hearing what Jeff and Tony have got to say about that. And we've invited these presenters because we hope that they, well, actually I know some of them will be controversial. So the idea is to promote some discussion which allows us to get beyond the niceties of things. The digital conversation with Marilyn and Alison. Digital is here to stay. We know digital is here to stay. But what digital should we have in our mathematics curriculum? And is it digital at any cost? Are we in danger of throwing the baby out with the bathwater? What sort of digital affordances do we need to take notice of? And then the assessment and the curriculum and the relationship between the two of them. We have very high stakes assessment in the UK, and so do they in many other international countries. How do we ensure that the assessment drives what happens in the classroom in a good way, so that it really does embody what the curriculum, the spirit of the curriculum, and doesn't detract from it? So, in March 2015, when we launched the manifesto, it was only me. I had some skeletal ideas. I look back now and think, how on earth did I have the cheek to stand up there and say something which was based on very little substantial research evidence, but I did. I knew what we wanted to do. I didn't really have much of an idea about how we were going to go about it, but I was helped by an awful lot of colleagues who gave me some support. How do you represent something as complicated as mathematics learning, which is what we're trying to do? What has already been done that we could learn from? Because there's absolutely no point in reinventing the wheel. How do we make sure that we talk to the right people? Who are the right people that we should be talking to? Where should we start? What skills do we need in the team? And who needs to do what? Well, you had, as a bit of pre-reading, a framework update. If you've done your homework, you'll have a sense and you'll understand and recognise some of the vocabulary that I'm going to use. That's the framework. Very pretty. Obviously, not very useful in that form. So one of the things that we have to do is to make sure that we have ways of surfacing or searching for different parts of it. There are just over 700 waypoints. Each waypoint contains some piece of mathematics. And we decided to use this network graphing software quite early on, because it allowed us to reflect one of our USPs, which was that we believe that mathematics is a set of connections. And so we needed to have some representation which allowed us to recognise that. There's a large database, and that underpins our authoring software, which is Neo4j, and eventually that will power what we offer to people who are going to use the framework. But this is our design tool. So for the rest of the day, please keep in mind that what we've been showing you is not what we intend people to use, but this is what we're using to design the framework. You'll notice that the number of nodes decreases from left to right, and actually they are in a sort of order. So the early mathematics is over on the left-hand side. The early mathematics is still ongoing, but it took us an enormous amount of time to get into, because there is so much that is written about the learning of early mathematics. And these nodes up here are sort of places that we've put in placeholders for later stuff. Not all of it is connected in. But we know that as we move through, there's more writing about the way that mathematics itself is connected, but there's much less writing about the learning of mathematics. It seems to be very much front-loaded. Ben, who is our software designer, and I'm going to embarrass him and say something nice about him now, he adapts and enhances the Neo4j software, and it means that this actually becomes a source of delight, I suppose. It's absolutely wonderful to have somebody in the team who can respond, sometimes even within the day, or even within the hour occasionally, to our requests. And one of the things that we hadn't predicted was that whereas our thoughts have gone into the design of this, and then Ben gives us the affordances that we want, but then by looking at the representation, it requires us to ask some other questions. So the very representation itself helps us to think of some things that we wouldn't otherwise have asked if we hadn't got this representation. So why is that node only connected to one thing? That node there seems to have a huge number. What does that represent? If a node has got 5 edges to it and this one's only got 3, what does that actually mean, mathematically speaking? As much of our content is research or evidence-based as it can possibly be, and we want to be as transparent as we can be with that. So if you imagine that this is one layer, you can imagine that we might have some other layers. So the one in the middle is the mathematical content. Some of the animations come up before it should have done. Oh, never mind. The mathematical content is the middle layer. And what we're doing is we're logging all of our research in a research base. And the interesting thing about that is that some research is connected just to one piece of mathematical content, but some research, as you can see, might be connected to a whole set of mathematical content, sort of a short pathway. There are some places where actually we can't find any research or evidence, and we think it's equally important that we make that transparent, that we say, we haven't got any research or evidence for this. This is the best that we know from talking to people who are working in the field. Ultimately, we're going to have other layers. So we're going to have layers which have tasks, classroom tasks, assessment tasks, maybe formative assessment, some summative assessment tasks, and some continuing professional development ideas. And because of the affordances of the network graphing software, it means that we can connect any layers to any other layers. So we can make multiple connections of whatever bits we choose to pull out. So, that's the sort of big picture. I think it's worth saying, though, and just reflecting back, Elizabeth talked a little bit about how we are part of the university. We're a university project, and so we want to reflect the aims of the university. And I think I said at the very beginning that what we want to try to do is to hopefully be able to contribute something which is meaningful and dependable and informative to the world of mathematics education. So there is a sort of philanthropic side to this. And the discussions that we're going to have a bit later on are fundamental to the way in which the framework will be enacted in different places. So I've got 4 grandchildren, and it's interesting, I was very concerned in my own children's education, but I'm absolutely passionate about my grandchildren's education. I suppose distance lends enchantment to the view, or something like that. I want their mathematics education to not be at the whim of political expediency or politicians' opinions, unless those opinions are underpinned by evidence. And I feel that extremely strongly. I want them to have a curriculum which the curriculum and the assessments and the pedagogy that are imposed on them will enhance their mathematics experience and not harm it. And by using something which is an evidence and research base, I hope that we can contribute that. And if we can bring together a coherent picture of the best things that we know about research, about the mathematics, about assessment, and about professional development, then, and we make that accessible to those people who not only make the policy decisions but also have to implement them, then maybe we will be able to contribute something for which Cambridge, unlike this week when it hasn't had a very good reputation, might enhance the reputation of Cambridge University. I'm going to ask the team now. I'm very blessed with a fantastic team. They say, surround yourself by people who are better than you, and I've done that really well. I'd like to introduce you to them. They've all got badges because they've all remembered them, because I told them they didn't get any supper tonight unless they did. So if I can introduce the writing team. So Rachael and Darren, where's Darren? Back there. And where's Tabitha? Are the main writers of the framework, amply supported by Lucy, who is in charge of research and comms, and Ellen, who does a fantastic job on the research side, Ben, who is our software magician, and at the back is Lynne. She's the other Lynne, and actually she's the really important Lynne because she keeps us all on track. So I'd now like to invite Rachael to come up and show you some of the detail about the framework, and then there'll be an opportunity afterwards for you to ask questions. Thanks.
I could stand here and go through an endless supply of functionality of the framework and how we think people might use it and show you all the different parts and give you lots of definitions, and you'd probably go away even less informed than you are at the moment, having done your homework, which I'm assuming you've done. Instead, what I'm going to do is I'm going to show you a case study. Now, this is something I actually did following some work we were asked to do, and I'll explain a bit more about that in a moment. Whilst I'm talking and kind of explaining the way that I use the framework in this, I'm also going to show you some videos. Now, this is the first time I've used videos, so does it never work with technology, children, pets, something like that? Anyway, I'm hoping it's all going to go according to plan, so you might have to bear with me. Things to explain are, firstly, the videos are taken from, as Lynne said, what we work with on a day-to-day basis. So what you see probably looks quite complicated. It's not what we envisage somebody who actually will interact with the framework using. And there's actually a lovely department, and they have a unicorn head on the wall, and they're all very creative, and it's an amazing place to go, called the User Experience Team at Cambridge Assessment. And we're actually being used as a trial for one of their projects, where they are doing some research for us to look at people like yourselves and teachers, what is it that they would interact with in the framework? How would they want it to look? What would be the default views they'd want to see, and what level of granularity they'd like to work with the content in? The other thing, since I am in a room of mathematicians, please don't concentrate on the maths content. We know it can be improved. It can always be improved. We know we might have wrong words here and there. Hence, a lot of what you see, you won't be able to read. There's a reason for that. It's to avoid you concentrating on the maths, which is a bit strange, I know. One thing I will say is we're looking for feedback. If you haven't already been contacted by Ellen, and I lost where Ellen is, she's there, and we are in the process of now having gone through an internal review period, we're now starting an external review period. So if you haven't already heard from Ellen to ask you to feed back on both the structure and the mathematical content, it's very likely over the next 6 months you will get an email off her asking, would you like to be involved? As I said, it's impossible to go through everything, so I'm going to give you a taster. Myself and the rest of the team will be around at lunchtime, armed with laptops, so if you'd like to see this close up, if you've got some specific questions, if you want to look at more detail, because I will just kind of touch the surface of quite a lot, please do come and speak to us. Bring your lunch, bring us a coffee. We'd be more than happy to answer questions. So, the area of mathematics, and this sounds a bit silly, the area of mathematics that I was asked to look into was area. That's not a mouthful, is it at all? Basically, I was asked to, for a variety of reasons, have a look at children's development of the concept of area. So obviously, poor performance from the work I was reading was often being attributed to people having learnt formulae by rote. Base times height and everything. I mean, the teachers in the room know you put anything and mention area, and it's either they add up the sides or they just do base times height no matter what shape it is. And from the work I was reading, a lot of that was put down to students, pupils not having really robust mental models of what an array is, what a rectangular array is. And that not only had implications for area, it also had implications for multiplication, because you use the array as a model for multiplication. It had implications for when you started looking at enlargement and scale factors of lengths and areas. And it also obviously had an implication for when you're starting to develop the formula for a volume of a cuboid. So it's a really, really important area. That's area. Oh no, this is going to go horribly wrong, isn't it? I was asked to write some sample textbook material for a curriculum that was already in existence. So I'm coming at this as a resource designer. I'm not coming at this as a curriculum designer. So the curriculum already existed. This is one page of that curriculum. And I was asked to write a chapter for a Year 4 textbook, and the learning outcome, and if I had a pointer I'd show you, so you'll have to imagine me showing you, it was find the area of squares and rectangles in centimetres squared and metres squared. That was this particular chapter of this textbook. So as obviously I would do, I started thinking, okay, I've got some ideas about this, I've been researching this recently, I've got some nodes in my framework area, oh grief. But the first thing I did was I read through the rest of this grade, and I obviously read through the preceding grades and the grades coming afterwards. And it was a bit of shock to realise that there was nothing about area before this statement. The word area did not appear once in this curriculum. And all of a sudden there was this one. So I was thinking, okay. And it got developed. There was mention of some properties of rectangles, there was mention of length and metric units and such like, but there was nothing else. And my problem was, how do I develop this chapter? Because I don't have control over the curriculum. How do I develop this chapter and potentially teacher support materials so that I am prioritising this conceptual development of the formula for the area of a rectangle? Which was something that was kind of expressed to us in the brief, that this was important, that it wasn't just about rote learning. Okay, so I thought, well, this is a really opportune moment to use the framework. My first job was to think, well, where am I going to finish? What's my end point? Well, my end point is I want students to be able to calculate the area of a rectangle and apply that formula and understand that formula and be able to apply it in different situations. Now, I'm fortunate. I am the main person writing a lot of the geometry part of the framework, so I knew one of those waypoints existed. If I hadn't known, I would have gone through a search and looked for keywords, or I could have followed the theme that we call area. But I knew this waypoint existed. There was a waypoint called calculating the area of a rectangle, and again, don't concentrate too much on the right-hand side because it's even moved on since here. But at that waypoint, this is actually a landmark, hence it's dark blue. I'm not going to explain what that is because you've all read your homework, so it's all okay. At that point, there's lots of information, and again, this is in the update. There's information about what that piece of mathematics is all about, why is it important, where is it going to lead to, and based on Malcolm Swan's framework, some information about the ways we would expect that to be performed upon, acted upon, played with, analysed, critiqued in the classroom. So I've got my end point. Now, what do I do next? So firstly, I wanted the big picture view. I want to know, where does this particular landmark node sit in the map of mathematics at that point. So what I was able to do, and you can see me going through this on here, I was able to start with that landmark node and work backwards. What were the other landmarks that contributed to that one? And the reason for doing this is I really wanted to confirm in my own mind the picture I already had. This was a kind of a confirmation exercise for me. Had I not already done the research, it would have been a kind of a starting exercise for me, really getting into what it's all about. I was in that position that I already had quite a strong picture in my mind of what this chapter would look like, predominantly because I'd just been reading lots of stuff and I'd just been writing all of these waypoints. The landmark map gave me that big picture, and this is the landmark map. And what it did is it identified those key moments in all of the parts of mathematics that somehow fed into this calculating the area of a rectangle. Looking at those, I was able to see what those landmarks were, how they were linked, so you'll see there's links to them. And you can't see it from where you are, but those links also identify how many steps it is between the landmarks or how close they are to each other, to give me a kind of measure for the strength of the link, and also the themes that were linking them. What were those themes that linked them? And what it also did was brought in other areas of mathematics. So although I'd concentrated on the geometry waypoints, this really gave me an opportunity to see what work of tabs in the number and what work of Darren's in the data handling was pulled in also. Now that gave me the kind of overview. Just looking at those landmarks was great, but I wanted to know, well, okay, give me more information about the links that do actually join them. For example, if I'm looking at early number, what is it that joins that in? So what I'm able to do then within the framework is kind of zoom in on that link between the two landmarks and have a look at the waypoints involved, and I could do my own little investigation. So this was linking in number to one of the sections of geometry, and I could potter around those waypoints, have a look at what the information was. The other one that I was quite interested in was this idea of the data handling, so I could do the same with that, and I could have a look at the grouping by singular attribute into calculating the area of a rectangle. And it was quite a big map, which is kind of what I was expecting. I wouldn't expect them to be very closely related, but it gave me an idea what was the content that connected the two together. So in this sense, with this map and investigating those links, I got a really good sense of where this mathematical content sat with respect to everything else before it and how it came in. So it didn't give me a guide for writing what I was going to write, but it gave me the big picture view. The videos are working. I'm quite pleased with this. Thank you. I should say this is more down to the rest of the team than me. This gave me a big picture. Now I was thinking, okay, I want some more detail. What is it that actually feeds into this final waypoint? And I could have done what does it go on to, but I decided to look at backwards. I decided not just to go back one step or two steps, because there wasn't anything I was building on at the moment in this textbook. I wanted to know everything that in some way had a path to my final waypoint. So on the right there, you've got my final waypoint calculating the area of the rectangle, and I've got all of the other waypoints that had some path that made its way there. Now, this was quite interesting, and I mean, it allowed me to investigate some of those. So you can see an edge along the bottom, a really long edge. Well, what is that all about? So I could investigate interesting characteristics. I could look at all of the landmarks from the previous map, all of the things that went between them, but then other things that were pulled in as well that weren't necessarily linked to one of the landmarks. So it gave me kind of a really good detailed overview, but obviously there's too much there to look at, but I could pick out what are the waypoints that have got lots of edges, connections that Lynne talked about earlier. What are some of those connections? What are some of those key places, and really investigate them. But it's too much information. There's no way I could develop my textbook chapter, which is supposed to be, 10 pages, 12 pages, on that whole map. So how do I start prioritizing? How do I get, again, another overview, but from a different perspective? So my next job was thinking about the connections. We've said connections is a key part of our work. So what are those connections in this map? So going through, I can see that many of the connections were what I was expecting. There are waypoints connected by 2D. There are waypoints connected by structure, units. There's some volume connections. So many of those would be what I would expect to see. Some of them stuck out. I could see the regularity of how many of them happened a lot of times. And angle, there were 30 connections with angle on them. Well, what's that all about? Why would angle be along a map that's talking about area of a rectangle? Obviously, there's measurement, but angle seemed a little bit strange. So just pulling out those angle edges, I started to have a look at that map and thinking about, well, why would angle be in a chapter or in a map describing area of a rectangle? And what it actually all came down to was one landmark node, and that was this landmark node called reading off measure. Now, reading off measure is a place where, and again, I knew this because I'd written the waypoint. I could have gone and investigated this place. I could have gone and read the research summary I've got attached to it. But I knew this was about connecting together length, connecting together with volume and angle, and talking about using measuring tools, identifying the correct measuring tool to use, using that measuring tool accurately. So the reason this came in, which I could then follow, was because of length. Length was a fundamental part. To work out the area, you had to know and understand length. So angle actually, although it was pulled into this map, it was through that reading off using measuring tools was the reason why it was important. So I could not ignore, it'd been raised to my kind of awareness, and that's what a lot of these connections are about, raising awareness and seeing where the connections are mass. But I realistically didn't need to worry about the area waypoints. So what I was able to do then was go back to all of those connections and decide which of them I wanted to prioritize. So I knew that I needed to prioritize 2D, obviously area, paths, the actual, it's not called length, it's called paths, perimeters, and lengths, because that's a whole reason behind that. I'm happy to have a conversation with somebody with. But I was able to then to kind of prioritize which of those connections I wanted to include in my map and filter out other things. Now, that meant I was able to produce a map that was much more tailored, I suppose, to the curriculum that I was working with. But it was still coherent, it still showed me the connections, it still made that story of how I got from no knowledge about area, linking everything in to the final place. Now, me being me, I wanted convincing again. And I was also thinking about, well, that's one way I could produce this map. Am I completely happy with it? And I interrogated those waypoints and started thinking about what I was going to do with them. But I also wanted to think about, well, is there any other way I could use the framework? Because I'm trying to do my dual purpose here, framework writer, designer, and user of the framework. So the next thing that I did was I had a look at that waypoint and I worked backwards, just one step at a time. So rather than producing everything, I mapped backwards. So I what we call expanded the two waypoints that fed into that one. Those two waypoints were finding areas of rectangles. And again, if you'd like to know the difference between that node and this node, I'm happy to show you at lunchtime. Now's probably not the time. And the other node that fed directly into it was multiplication as area, which I would assume doesn't come as a big surprise to anybody in the room. So the finding areas of rectangles was kind of what I would expect. The multiplication as area was what I was expecting, but I wanted to know more. So I was then able to expand that waypoint and look at everything that was connected to it, potter around those nodes. I use potter quite a lot. I tend to do that. Have a look at the content, have a look at the student actions, the what, the why, and really get a feel of why this was an important topic, why this was an important concept for both myself in geometry, but also in the area of number. And also then I was able to follow off those number waypoints to see where it's heading. So it really gave me a good understanding of where this topic fits with everything else. When I investigated the other waypoints, the one I was expecting, finding areas of rectangles, I recognized the fact that there was some waypoints about Cartesian coordinates. And this was due to developing the idea of calculating area of rectangles on a Cartesian plane. And I knew, having worked with the curriculum I was working with, that they weren't looking at Cartesian coordinates at all. So because of the curriculum I was working with, I was able to say, I don't need to include those waypoints in my map, so remove them. And working in this way, this kind of backfilling, I was able, again, to produce a really nice submap for my chapter. And that then formed the backbone of what I wrote. Everything was tailored to the curriculum, but I didn't have a disconnected map. Everything was connected. Everything made a nice, coherent story. And then by investigating the information at the waypoints, I then had the kind of the detail that I was looking at to write the chapter. One of the questions I've been asked by a colleague who is a teacher for one of the local trusts who I used to work with, she said, how did I get from that to my chapter? Because it wasn't actually that map. I'll show you the map in a moment that I worked from. And I said, well, I knew where I was going to start because it was one of my exploratory nodes. And again, that's in your homework. And I was able to kind of follow the routes through. And when I got to another place, I was able to say, well, I've got a choice now. I can either keep following this route through, but actually I'm going to introduce this new little part and this new little part. So I was able to build a really good chapter that worked through from nothing to developing that formula. So that gave me my map. I was happy. I wrote the chapter. I'm happy to, well, I might be happy to share it with some people, I don't know, it depends how horrible you're going to be. The other thing that we're doing as a writing team is carrying out a huge amount of research ourselves. And we do a lot with Lucy and Ellen, but we also write some of the short pieces as a form of explaining our decisions that we make. Lynne talked about transparency and being able to kind of tell people why we've done what we have. So for certain what we called saved searches, so that's a group of waypoints that we've collected together, there's a particular story behind. So for example, this particular research summary was about early measurement and calculation. So each research summary has really three main sections. The first is a brief literature review that kind of covers the key findings we've read and have picked out and chosen from research papers that have informed or influenced. Might also be discussions. So a recent one I wrote about the differences between volume and capacity had more to do with discussions I had with curriculum designers in Japan and America than it did with the research I'd been reading. They also then contain an implications section. So how has that research, what has it done to those waypoints? Where can you see those key findings in the waypoints? And obviously the third section is the actual papers themselves so that people who are interested can go on and follow up. These are aimed at a selection of people. We would hope that people in the room, for example, would be interested in reading them to see why what they're looking at looks the way it is. The aim is for teachers to look at them if they have a particular area that they want to, what's that word, area again? If they want to investigate a particular area of mathematics. Also potentially curriculum designers, if they're having a bit of a battle and they want some evidence to say, well, you know, it's this because it's this, and they themselves don't have the time to go off and do the research. Here is the reason why we've designed it the way we have. These are already out. A couple of people in the room have already given us feedback on some of these, which we're really thankful for. And the aim is hopefully that these will be quite numerous and will really kind of explain the decisions that we've made and the way that the nodes fit together and the content of some of those as well. Last thing. So I've talked about one case study. I've talked about how I used the framework in a multiple set of ways to produce the backbone for my chapter. I've shown you kind of one of the ways that we're sharing the research with people. The other way we're doing with it, to any view in the map that you want to, you can always see what research papers have informed that part of the map. Because what we're able to do, so this is the saved search for the previous research summary. For any of the maps, any view, whether you're in a saved search or whatever, you can just bring up the research papers that have informed those specific waypoints. And then we also catalogue those on, I think catalogue's the right word, we catalogue those on something called Zotero and take our own notes on Zotero. So everything we're able to backtrack and we're able to have conversations about, well, that exists because of this. We might not be able to tell you immediately, but we'll be able to find you out the information. The last thing that I wanted to show you, which is relatively new, and this is our glossary. So you will have noticed possibly in some of the other waypoints that some of the words came out highlighted blue. And what we're actually now doing is mapping in a glossary. This was a pre-existing one. It's the QCDA one, which is used widely by a number of people. So we're using that as a starting place, but we're also putting in other glossary terms that are important to us. And that will be refined and added to and adapted as we carry out the work we're doing. So it's been quite a quick trip. Hopefully, I've given you an insight into one specific use of the framework and how it helped me. ideally what I'm doing is also making you think, well, could it do this? Could it do that? Would I be able to do this? Wouldn't it be great if it could? Now, those are the kind of questions we'd be really keen to speak to you about lunchtime, because it's possible we might already be able to do that. Or if not, we do have Ben here, and he's quite quick at programming new things, so I'm sure by the end of the day we might be able to do it. But we really would be keen to kind of talk to people and learn about and hear about how you could envisage this being useful to you. That's it.
So we've got about 10 minutes for questions. Do you want to just have a couple of minutes on your tables just to unburden yourself of your thoughts from that and formulate some questions? And I'll come back in a couple of minutes and take some questions. Any quick fire questions? As Rachel said, all the team are going to be out with their laptops at lunchtime, so if you'd like to come and see things in more detail. Anybody got any general questions, though, that they would like to offer? This is where everybody avoids eye contact. Alison.
Yes, the question I wanted to ask is, what's the nearest thing out there that exists, or bits of this that exist, for mathematics that we're aware of? I mean, I was intrigued to know if anyone on my table knew of anything similar. I think my nearest connection is the thesaurus that I think came out of the Enrich team 20 years ago.
Which had a similar connectivity, didn't it?
Which was focused on mathematical words and the connections and hierarchies between them. But a genuine question to the audience, really.
If you throw that back to Ellen will... Oh, she's got one, sorry.
So there are a number of things that we have looked at that have a similar structure or approach. For example, Jira Confrey has been doing a lot with the Common Core curriculum, which is a curriculum that's already been developed, but now it's being expressed in a way that is connected, that makes visual reference, that also helps to structure the research reference. And then off of the back of that, her group at SUDS has built a set of teacher support materials that further help to link pedagogy to this structure to improve coherence. So in that context, that's something that I think is very similar.
And the OECD?
Yes, there's something that's in progress right now, and we haven't yet seen this level of detail that you've been looking at from them. They've just done a public consultation on the subdomain level, but they're building a mapping framework that's meant to link, I guess, theoretical views of learning with assessment frameworks and curricula in different jurisdictions. And I think it has a predominantly assessment focus, but they're, I would say, only probably about halfway through their project right now, too.
So one of the things that's very important for us is not to reinvent the wheel, but to work with people who are doing similar stuff so that we can learn from them and maybe offer them something as well. Thanks, Alison. Anybody else? Yes.
What's the difference between your map and Jira Confrey's map? Jira Confrey's map is
Hers is
very comprehensive,
yeah.
very research-based. Okay, she's from the United States. Maybe there are differences. I don't know. I have no idea.
Hers is, if I remember rightly, Ellen will put me right if I'm not right, is a set of hexagons. And so whereas we can have hexagon only has 6 sides, so you can only connect possibly to 6 different things. Whereas ours, we can have as many connections as we want and cross across areas of mathematics, whereas Jira's is very much within the areas of mathematics.
And that has to do, that has to do with how she's chosen to visualize this for a certain audience. And of course, what's underlying it may be more like what you see here,
yep.
But then that's not necessarily accessible. So there are many trade-offs to be made, and you could use similar approaches to make a lot of different decisions and come up with some very different designs.
Okay, we're going to have an opportunity to do some more questions a little bit later on, but I'm going to invite Lucy to come up now to just tell you a little bit about her work.
Welcome everybody, and thank you very much for coming today. I'll just reiterate that. If you haven't met me, Where have you been? I've been out and about talking to lots of people about what we do at Cambridge Maths, and I have a wonderful dual role, which is partly working in the project and partly talking to people from the outside. And so I get this wonderful view, which I'm hoping you're getting a slight picture of today, of how great the project is. And really, it takes me back to the sorts of feelings you'd get, and this is a room of very high achievers, I think. So just imagine for a moment your school days, and imagine when you were invited to do some sort of project, which is usually a kind of Mott and Bailey construction of that kind. It's always that, isn't it? Or something that you spent a lot of time on, and you came back to school and you brought it in, and you knew it was good. You had that sort of glow of quality. And presenting that, to your teacher, and that feeling you got when you'd done a really good job. And that's kind of how I feel every day with this project. And, that's a wonderful thing to be part of. And I'm here just to talk about something which is slightly separate to the framework, but very much converging towards it. You may at this point have coffee on your mind, I imagine. We're going to break for coffee very shortly. And it's no accident that this is the time for me to talk about espressos. And so you may just enjoy that quote for a moment, which is how I normally begin talking about espressos. I'll just let that sink in. I talk to teachers about educational research often, and there are many, many barriers for teachers to access educational research, and I imagine most people in this room are all too aware of some of those barriers. And we know that it's not just about teachers and anyone in the education community reading research, it's about engaging with in all of the ways that happens, criticising, using, thinking about, feeding back on lots of ways in which teachers and researchers and anybody involved in education can work better and be more connected. And if you haven't quite caught that the buzzword of the day is connected, then I'm saying it now. We've said connected many times, I'm saying it again. For lots of teachers, the first barrier is just where to start. And I began, with some of my work on this project, to consider this lovely problem of how we could better connect teachers with educational research, specifically in mathematics. And that, for me, was a most wonderful problem to work on because I am an ex-maths teacher, or I'm a maths teacher. I mean, you never really leave, do you? So that idea of how I might, in some small way, contribute to making some connections there was immensely exciting to me and continues to be immensely exciting to me. So espressos were born, or brewed, if you prefer, or poured. And espressos are very simple documents that are supposed to be teacher-facing, which help to, in some way, distill the research that we're doing at Cambridge Mathematics, but specifically for a teacher audience. So we defined, when thinking about espressos, some really important design principles that reflected those of the framework itself. So they had to be accessible, they had to be coherent, they had to be research-led, and I hope it goes without saying they had to be useful, otherwise there was absolutely no point at all. In order to be accessible, there are 2 pages of text only, with interesting quotes, an infographic, and a limited number of boxes of text with a clear summary at the beginning. In order to be coherent, they are focused, where possible, on research questions that are not limited to one key stage or setting, and they attempt to consider the research evidence overall in a balanced manner. In order to be research-led, they're the product of a careful review process involving the whole team, expert consultation, and the original research papers are available as clickable links on the document. Finally, in order to be useful, each small box of text contains classroom implications, and the whole document is freely available as a PDF at cambridgemaths.org. We're now in the second stage of developing espressos, one where the researchers themselves are approaching us to write them collaboratively, and one also where we're beginning to evaluate their impact. We invite you now, therefore, to pick up an espresso with your coffee, which is now served, and we would be absolutely delighted to hear your feedback. We have a 15-minute break for coffee. Espressos are available to have a look at. I currently have 11 written and a few more in the pipeline, and I'd be delighted to talk to you about them. Thank you very much.